Hi, hello my dears, welcome back to Physics Wala. Good afternoon everyone, how are you? Hello everyone, good afternoon. Hello my dear kids, so today we are going to start with our second chapter, that is electrochemistry, and that is very important chapter for our boards. So we can begin the session, right? Everyone is ready, right? Everyone had lunch? Okay. So we can start the session from the electrochemistry, that the basic section we learned in class 10, that redox reaction, and 11th also we learned a chapter related to the redox reaction, right? So we are familiar with the redox reaction. What is meant by redox? Can anyone tell the answer? What is redox reaction? What is redox? It's in the name itself, right? So, redox reactions are classified into two types, direct redox reactions and indirect redox reaction. So, we learned about the direct redox reaction in class 11 and indirect also we learned, but not like the word indirect redox reaction. We only learned about redox reaction. So, it is in the word itself, redox. What is the redox? Red means reduction and ox means what? Oxidation. So, redox reaction means oxidation and reduction occurring simultaneously or at the same time is known as redox reaction, right? So, what is the definition for redox reaction? Reduction and oxidation occurring at the same time. And if it is carried out in the same container, it is known as direct redox reaction. And if it is carried out in two separate containers, it is known as indirect redox reaction. So, redox reactions are classified into two types, and this is for our NEET JEE level exam, not for our board exam, because we only need redox reaction, not about the like direct or indirect redox reaction, but we will learn both, but not in the name like direct or indirect. Okay, got it? Hello. Okay, so first we can learn about the redox reaction, the general thing, what is meant by redox reaction. Okay. So, it's from the word itself, it is understood that red means reduction and ox means oxidation. So, it is a combination of reduction and oxidation. Reduction plus oxidation. And we are familiar with reduction and oxidation, right? What is by reduction and what is by oxidation, my dears? What is by reduction? Reduction means losing of electron or gaining of electron. What is reduction? So, first we can go to the topic oxidation and reduction separately. We want to learn about oxidation and reduction. Then we can go to the chapter. Then only we will be able to understand about the reaction happening inside the beakers. What is cell? What is battery? Okay. So, what is meant by oxidation? Oxidation means increase in the oxidation number. What is it? Increase in the oxidation number. So, what is oxidation number or oxidation state? What is oxidation number or oxidation state? Increase in the oxidation state, we can write like increase in the oxidation state. The number of electrons lost or gained for attaining stability is known as what? Valency. For example, if we are taking oxygen. Oxygen atomic number is what? 8, right? Yes, we will complete the whole chapter in this one session, okay? So, oxygen atomic number is 8 and we will write the configuration like 2, 6. Is oxygen stable? No. So, oxygen require 2 more electrons for attaining the octet configuration, that is outermost shell contains only 6 electrons. It require 2 more electrons. So, it will become 8. Okay. So, oxygen is not stable. So, it will add 2 electrons. Right? So, oxygen needs 2 electrons. Then, what about in the case of sodium? Sodium, it is 11. 11. So, the configuration will become 2, 8, 1. Sodium is also not stable. Outer shell contains only 1 electron. Is it stable? No, right? So, what sodium will do? Sodium will lose the 1 electron to attain the configuration 2, 8 octet configuration. So, what happened to the sodium? Sodium loses 1 electron. Loses 1 electron and it will change into sodium plus 1. Then, losing of electron, the charge will become positive. What is it? Losing of electron, the charge will become positive. That is known by oxidation. Increase in the oxidation number. So, beginning, the charge of sodium was what? Nothing was it like 0, right? Sodium was in 0 state. When sodium lost 1 electron, and it changed to a configuration like 2, 8 and attained the stability. So, the charge becomes sodium. What is it? Plus 1. Sodium loses 1 electron. It changes to Na plus 1. Why it is Na plus 1? Lost 1 electron. So, losing can be shown by plus test. So, sodium become Na plus 1. Clear? Got it? Any doubt? Okay. So the charge increased. So increase in the oxidation state is known as what? Oxidation. And three more definition we learned. The other one is what? Loss of electron. Loss of electron is also known as what? Oxidation. And addition of oxygen is oxidation. And removal of hydrogen is what? Oxidation. That definition we learned in class 11. Okay, so there are four definitions for oxidation. Increase in the oxidation state, loss of electron, and the other one was what? Addition of oxygen and removal of hydrogen. Got it? Clear? Okay, right? Okay, then we can go to reduction. So oxidation is clear. Now we can go to reduction. Reduction. Reduction means what? That's the most common familiar word, right? It's a basic word that we use in our daily life also. Reduction. Reduction means what? Decrease. Decrease in oxidation state. Okay, decrease in oxidation state is known as what? Reduction. For example, we can take the example of oxygen. The previous one. Oxygen atomic number is 8. Configuration will be 2, 6. Outermost shell contains only how many electrons? How many electrons are there? How many electrons are there? 6 electrons, right? Is it stable? No, right? Octet configuration is not satisfied. So it requires 2 more electrons for attaining the stability. So oxygen is adding 2 electrons. Oxygen adds 2 electrons. So it will change into addition. Add. That means gaining of electron. When the electrons are gained, the charge will become negative. Gaining of electron, the charge will become what? Negative. Okay. This is for our NCERT CBSE class 12 board exam. Okay. So, gaining of electron, the charge become what? Negative. So, oxygen changes to how many electrons are added? 2 electrons are added. So, oxygen becomes O2 minus. When electrons are added, the charge is negative. Learn that is very, very important. When electrons are added, the charge become negative. When electrons are loose, the charge will become positive. So, oxygen adds 2 electrons here. So, oxygen changes to what? O2 minus. So, what happened to the oxygen? In the beginning it was 0. When the electrons are added, it changed into 2 minus, the charge decreased. The oxidation state is decreased. Clear? Got it? Any doubt? Yes, yes. Okay. So, what happened to the oxidation state? Oxidation state is decreased. Now, what is the other definition? Reduction means gaining of electrons. Electrons are gained, and addition of hydrogen and removal of oxygen are the other definitions of reduction. So is that clear? Now we can go to the redox reaction. What is redox reaction? This is the same thing that we discuss now. Properties. Oxidation, reduction. Hydrogen is lost in oxidation, gained in reduction. Oxygen is gained in oxidation, lost in reduction. Then what happened to the oxidation in case of electron? Electrons are lost, electrons are gained in reduction. So if you study this table, it will be very useful for you. Okay, everything is given for oxidation and reduction. Then what about the oxidation number? Oxidation number increases in the case of oxidation, reduces in the case of reduction. So got it? Clear? Okay. Okay, then we can go to the next one. Oxidizing agent and reducing agent, or oxidant or reductant. What is by oxidizing agent and reducing agent? It's very easy to learn. Oxidizing agent means which undergo reduction, just opposite. Agent means what? Helpers are known as agents. Okay, so the substance which help for oxidation. The substance which help for oxidation is known as oxidizing agent, and itself will undergo reduction, just opposite. The substance which help for oxidation is known as oxidizing agent, and itself it will undergo reduction. Clear? Then next one, and they will gain electrons. Just then. Next one, reduction, a reducing agent. Reducing agent means what? It helps for reduction, itself undergo oxidation. It undergoes oxidation and helps for reduction. Now we can take an example and explain the reduction. Okay, and oxidation and the whole process. What is happening in oxidation, reduction occurring together, and the name of the reaction that you already know, right? So now, let me see. Okay, for example, consider the reaction. It's like everything is given. So we can take separately and we can discuss. Okay, done? So we are going to the first reaction, that is the commonly used reaction, zinc plus copper sulfate. What will happen? I will show you a picture, then you should explain what is happening here, okay? I will draw a beaker. So I'm taking a beaker and the beaker is filled with, what is the color of copper sulfate, my dears? What's the color of copper sulfate? It's a blue color, right? So copper sulfate, I'm going to fill this beaker with copper sulfate solution. So in this beaker, it is completely filled with copper sulfate CuSO4 solution. Aqueous CuSO4. Okay. Now, I'm going to dip a zinc rod in this beaker. A zinc rod. Okay. A piece of zinc metal. Zinc rod is dipped. What happens in the beaker? Can anyone tell? What is happening inside the beaker here? Copper sulfate is taken in a beaker and a piece of zinc metal, that is a zinc rod, is dipped in the beaker. After some time, what will happen? The blue color fade. The blue color of the copper sulfate solution fades and changes the color. Why? What is the reason? You know? For this thing, we should know the reactivity series that we learned in our lower classes. What is reactivity series? The arrangement of metals based on the order of their reactivity. Right? So, which metal is coming in the top of the reactivity series? What is the reactivity series? Reactivity series, the order of metals arranged in the order of their reactivity is known as what? Increasing order of reactivity. Which metal is showing the highest reactivity? Which metal is showing the highest reactivity? Anyone can comment that answer? It's very, very important. Which metal is having the highest reactivity? Who will say the answer? We can wait. Which metal is having the highest reactivity towards water, towards acid, everything, oxygen? No one is answering. Why? Which metal is having the highest reactivities, my dears? That is potassium. Then next one is sodium, calcium, magnesium, aluminium, zinc, iron, nickel, tin, lead, hydrogen, copper, silver, gold and platinum. This is the order of the metals arranged in the increasing order of the reactivity. Okay, and up to this, up to the hydrogen, these are the metals, and down the hydrogen, copper, silver, gold, platinum has the least reactivity, and the potassium, sodium, calcium has the highest reactivity, and out of these metals, potassium shows the highest reactivity. And we learned that a highly reactive metal can displace a low reactive metal from its solution. That reaction is known as what? What is the name of that reaction? Displacement reaction. So all the displacement reactions will be redox reaction, that we can check. Okay, displacement. First, we should know what is displacement reaction. Displacement reaction means a highly reactive metal displaces a less reactive metal from its solution. For example, this is zinc. Just compare the two metals that we took here. Which are the two metals? One is zinc and the other is copper, right? One is zinc and the other is copper. When we compare the reactivity of both, zinc, where is zinc here? Zinc is coming first, then copper is coming last, right? So, when we compare the reactivity of zinc and copper, zinc is showing more reactivity compared to copper. Got it? Zinc is having more power, more strength. So, what will zinc do? Zinc will leave the copper? No. What will zinc will do? Zinc will remove the copper from its position, displaces or substitutes. That means the zinc will come and sit in the place of copper. Copper will go from its place and it will leave from its position. So that is known as the displacement reaction. The highly reactive metal displaces the less reactive metal from its solution. What is the solution here? Copper sulfate. Okay, clear? So we can look here. Here it is copper sulfate. So what will happen? Zinc is having more power. Zinc will come into the solution. So what copper will do? Copper will go from the solution because zinc is coming. That's why copper sulfate blue color is fading. The copper sulfate blue color is only due to the copper. So when copper is going, the color won't be there because zinc is coming to the place of copper. So what will be the new product in the beaker? The new product in the beaker will be what? It will be ZnSO4. Okay. It will be what? ZnSO4. On the road, it will be what? Copper. Copper is displaced from the solution. Got it? So that is displacement reaction. Now we can write the that equation, the complete equation showing the oxidation and reduction, and you are familiar with oxidation reduction, just recall the chapter redox reaction that we learned in class 11, the same thing that we are going to use here, okay. This is a reaction that is happening there. Before that, we can go back to the first reaction. Zinc plus copper sulfate, what is happening there? 7SO4 plus Cu. And they are writing the different equation, that means oxidation reduction, that we can write separately, okay. You should take a book and a pen and write with me, then only it will be clear for you. Write the oxidation reduction separately and we can combine the both and form the redox reaction. Just check how we can write, okay. So first take the main reaction. What is happening here? We took zinc and it is placed in a copper sulfate solution, aqueous copper sulfate. So what happens here? Zinc is having more power, more strength. When we compare the reactivity series, zinc is highly reactive metal compared to copper. So what will happen here? Zinc will displace the copper. Zinc will displace the copper and will sit in the place of copper. So the product will be what? ZnSO4. And what will copper do? It will move right. It will move from its place. The copper will move and it is displaced from its position. So copper is removed. Now we are going to write the oxidation states. And if anything is alone, if anything is in the elemental state, the charge will be what? 0. Elemental state. Elemental means free state. Elemental or which state? Free state. If any elements are in the elemental state or free state, the charge, the oxidation number will be what? It is equal to 0. So when we get an equation, when we get a reaction, we should check which are the elements are in the free state or elemental state and give the charge 0 here. So tell, in this reaction, which are in the elemental state or free state, look at here, zinc. Only zinc is there, right? Only zinc is there. No one is along with the zinc, so it is alone. So elemental or free state means what? Alone. No one is there. Okay. So the charge of the zinc will be what? We can write here 0. Clear? We can write the 0. Then here, anyone is alone? No. Copper is along with sulfur. Sulfur is along with oxygen. So it's like a group. So we cannot give 0 there. Here also zinc is along with sulfur is there, oxygen is there also, it is not possible. Now we come to the copper. Copper is also alone there, copper is in the elemental state, free state, so we can give the number 0. Now we can mark the charges of the other elements. We know to calculate the oxidation state, right? What is the most commonly showed oxidation state of copper, sulfur, oxygen? SO4 we know. What is the charge of SO4? If you don't know, learn the charges of the main groups. I will write here the main charges. Hydrogen, sodium, potassium, they show +1. Then oxygen show -2. Magnesium, calcium, zinc, copper show +2. Then SO4 show -2. Nitrate, NO3 also -2. So these things you should know. It's not -2, NO3 is -1. Carbonate, CO3. -1. So learn this, that is very, very important. Okay. Okay, that table is very, very important. Okay, now we can give the charge. What is the charge of SO4? SO4 is -2. So copper will be what? Opposite +2. If SO4 is -2, just opposite write the charge. Copper will be what? +2. Then here also, zinc is +2. Copper sulfate is -2. Now we are going to mark the oxidation and reduction. How we will mark the oxidation and reduction? What happened to the zinc? In the starting, just look at the left side. In the starting, zinc is having a positive charge, right? When zinc is having a positive charge, after becoming the product, it changed into +2 charge. So the 0 changes to +2. What happened to the charge? It is increased or decreased? The oxidation number is increased. The oxidation state, right? Oxidation state changed from 0 to +2. So the charge is increased there. Clear? The charge is increased. So we can write increase. Increase means what? When the charge is increased, it is known as oxidation. What is it? It is known as oxidation. When the oxidation number is increased, it is known as oxidation. Now we can look the copper. SO4 no change. SO4 here also same. When? What happened to the copper? This is our copper. Copper is +2. When it goes to the right side, the product, what happened to the copper? It changed into 0. +2 changed into 0. What happened to the charge? The charge decreased. So the reduction. Decrease in the charge is known as what? Reduction. decrease in charge is known as reduction. Is that clear? Okay. This is completely pure English class, okay? It is not in Hindi class, it will be in English only. Okay, so the charge decrease plus 2 is changed into 0. 2 changed into 0, that means the charge is decreased. That process is known as what? Reduction. Now, just look at the reaction. Oxidation and reduction occurs at the same time. Oxidation and reduction occurring at the same time is known as what? Redox reaction. Oxidation and reduction occurring simultaneously is known as what? Redox reaction. That is very, very important. Now look at the reaction. Zinc undergoes oxidation and copper undergoes reduction. In the same reaction, oxidation and reduction occurs. So it is a redox reaction. This reaction is an example for redox reaction. So what is my redox reaction? Redox reaction means reduction, oxidation occurring at the same time. Clear? Got it? So, this reaction we can write like zinc plus Cu2 plus gives Cl2 plus Cu. That means just remove the SO4 and we can write like zinc is there, copper 2 plus is there. What happened to the zinc? Zinc change into zinc 2 plus plus copper. So this is the reaction. This reaction can be rewritten as like this also. That is also possible. Okay, same thing. Then next similar reaction, another example is given. Cu plus 2Ag NO3 gives CuNO3 twice plus 2Ag. That we can write Cu plus 2Ag NO3. Cu plus 2Ag NO3 gives CuNO3 twice plus 2Ag. This is the next question for you. Okay. So try to solve which metal undergoes oxidation and which undergoes reduction. Who will give the answer? Yes, I know, Blessy ma'am. You got the answer? Which will be undergoing oxidation and which will be undergoing reduction? Okay, thank you. Ag reduction. Okay, then which undergoes oxidation? That we can check, right? Copper. Anything in the elemental state, we want to give the charge. How much will be the elemental state oxidation number? 0. Here copper is alone, so we can give 0. And who is alone here? Ag is alone, so Ag is 0. Now we can mark the charge. Silver is having positive charge. NO3 is having a negative 1. Copper, here it will be positive 2. Here it will be negative 1. Now mark the oxidation reduction. Copper 0 changed into copper plus 2. 0 changed to plus 2. Yes, very good. Correct answer. Correct answer. So, copper changed into plus 2. That means what? Oxidation. Now, what happened to Ag here? Ag is plus 1 and on the other side changed to 0. It becomes reduction. Plus 1 changed to 0, so Ag undergoes reduction. So in this reaction also, oxidation and reduction occur simultaneously. So it is an example for what? Redox reaction. Clear? So now we can go back to the chapter, that is, what is the name of our chapter? Electrochemistry. Till now it's like a base that we already learned in class 11. Now we are going to start our chapter class 12, second chapter, electrochemistry. So what is my electrochemistry? Electrical energy converted into chemical energy or vice versa. Chemical energy, Ag is reduction. Okay. So what is happening here? What is happening here? What is by electrical energy? Okay. Electrical energy into chemical energy and vice versa. Okay. Chemical energy and chemical energy into electrical energy. Chemical energy into electrical energy. This conversion we are going to learn in this chapter. Okay, electrochemistry means what? It's a study of Redox reaction we already discussed. Oxidation is there, reduction is there. Then electrochemistry is defined as the branch of physical chemistry which deals with the study of conversion of electrical energy from chemical energy which is produced in a redox reaction, or how to get redox reaction using electrical energy which is other non-spontaneous. That means in electrochemistry chapter we will be dealing with the study of a physical chemistry branch. We will be studying the conversion of electrical energy to chemical energy and chemical energy from electrical energy, that is vice versa, with the means of redox reaction, oxidation and reduction. Is that clear? Got it? Okay. Now we are going to the chapter that is electrochemistry. The first one we are going to study about the process of making electricity from chemicals. That is chemical energy converted into electrical energy, and that setup is known as what? Electrochemical cell or galvanic cell or voltaic cell. Three names are there. That is very, very important. The first topic of our chapter. What is it? Electrochemical cell, galvanic cell or voltaic cell. The same thing that we discussed now. We can come back to this one. The reaction. This is the first topic, that is galvanic cell or voltaic cell. That is an electrochemical cell. Electrochemical cell. So before that, draw this table. That is very, very important. Electrochemical cell means chemical energy is converted into electrical energy, and the vice versa. Opposite is what? Electrical energy converted to chemical energy is known as electrolytic cell, and both will use redox reaction. Okay. So electrochemical cell concept came from the study of redox reaction, and the electrochemistry is classified into two sections. That is first one, chemical energy into electrical energy, electrical into chemical energy. Chemical to electrical is known as what? Electrochemical cell, also known as galvanic cell or voltaic cell. And the opposite is what? Electrical energy converted into chemical energy. That cell is known as electrolytic cell. So we are going to learn about two types of cells and the reactions happening inside the cells. Okay, clear? Got it? So the first one is a galvanic cell or voltaic cell. Galvanic cell or voltaic cell. So what is by galvanic cell or voltaic cell? The cell which converts, so first learn the definition. The cell which converts chemical energy. The cell which converts chemical energy into electrical energy. Is that clear? The cell which convert chemical energy into electrical energy by the means of redox reaction. With the help of what? Redox reaction. The cell which converts chemical energy into electrical energy by the means of redox reaction is known as what? Galvanic cell or voltaic cell or Daniell cell. So here we are given a picture of Daniell cell. Daniell cell is constructed with zinc and copper. Okay, so we are going to learn about the construction. That is very, very important. So look at the picture. Here we took two beakers. Two beakers are here. One beaker is filled with zinc sulfate and the other beaker is filled with copper sulfate, two solutions. Okay, and in the two beakers, two metal rods are placed. Where is the metal rod? Where's the metal rod here? This is a metal rod. Two metal rods are dipped in the solution. Here one and the next one. And in zinc sulfate, I will draw, okay. So we are going to draw the construction of the Daniell cell. It's an example for the galvanic cell. So two beakers we took. In the two beakers, we are going to fill the solution. First beaker, we are going to fill zinc sulfate. What is it? Zinc sulfate, and the other one is filled with copper sulfate solution. What is it? Copper sulfate solution. In the two beaker, we are going to immerse two metal rods. In the first beaker, it is zinc sulfate, so we are going to immerse the zinc rod in it. Okay, a piece of zinc metal. So here we can draw the metal piece, zinc metal. Okay. Zinc metal, and the other one we are going to draw a copper metal piece. Same metal we are going to use, okay. So the construction is completed? No. We want to connect, right? We are producing from the chemicals, we are converting the chemical energy into electrical energy. So for that purpose, these two metal pieces are connected to a voltmeter. Okay, two metal pieces are connected to a voltmeter like this. And there is no connection with the beaker. For that, a U-tube is connected between them. Okay, a U-tube like this. And that U-tube is known as salt bridge. Why it is getting the name U-tube? Why it got the name U-tube? Because it is having a shape of U-tube, that is inverted U-tube, that will connect the two solutions. Okay, is that clear? So this is the construction. Now we are going to mark the things. So this is the zinc rod. What is it? Zinc rod. And this is copper rod, Cu rod. And zinc rod will be the anode. Zinc rod is what? Anode. Copper is the cathode. Copper is cathode. And cathode will be positive. Learn the sign, that is very, very important. Cathode is positive and anode is negative. And negative means highly reactive metal will be always the anode. Just look at the two metals that we took. One is zinc and other is copper, right? When we compare the reactivity, zinc is having more reactivity. Zinc is having the more reactivity. So zinc will be anode. Copper is less reactivity. So copper will be cathode. Cathode means it always undergo reduction. Cathode undergoes what? It undergoes reduction. That is very, very important. Learn that, okay? Cathode undergoes reduction. It is having the sign positive. Anode is having negative sign. It undergoes oxidation. It undergoes oxidation. Now, can you tell what will be the flow of current in this circuit? In which direction the current will flow and which direction the electrons will flow? The current will flow from which direction to which direction? It's very easy. Just look. Current is always positive. No, we'll be getting shocked. No, current is always positive. So the current will flow from positive to negative so that we can mark from cathode to anode like this. The current will flow. I is the current, okay? I. Current will flow from positive to negative. When current is flowing, what is that? Due to the flow of electrons only. Due to the flow of electrons only, the current will flow, right? So electrons will, what is the charge of electrons? Electrons are negatively charged. So the electrons will move from which direction to which direction? The electrons will move from negative to positive like this. Like this, electrons will flow. So the two main questions asked from the section are the direction of flow of electron is from anode to cathode, that is negative to positive, and opposite to that the current will flow, that is cathode to anode, positive to negative. Cathode to anode, the direction of flow of current, and negative to positive, that is the direction of flow of electrons. Is that clear, my dears? You got it right? So can we go to the other session? So, we are going to write the equation of the galvanic cell, the Daniell cell, and the Daniell cell is constructed using two metals. Which are the two metals? Zinc, zinc sulfate, copper, copper sulfate. It is connected using a salt bridge. This is the construction. Construction is very, very important. Learn the construction, and the voltmeter is connected to measure the electricity. So, the chemical energy is converted into electrical energy by the means of redox reaction. And where will be the redox reaction happening? And in this beaker, oxidation will happen, and this side reduction will happen, and this section is known as oxidation half cell, and this is reduction half cell. When we add both half, we will get one full, right? Half plus half, it is full, right? It's one full. So oxidation half cell plus reduction half cell, it will together make a total redox reaction. Oxidation and reduction occurring at the same time is known as redox reaction. So where is oxidation happening? In the zinc beaker, and reduction is happening in the copper beaker. So when we combine the both, we will be getting the complete redox reaction. So how we will write the equation here? So zinc plus copper sulfate. What will happen? Zinc plus copper sulfate, it changed into ZnSO4 plus Cu. Now, zinc is 0, ZnSO4 will become plus 2, copper is plus 2, here it will become 0. Now, zinc is changed into plus 2, that means oxidation, zinc undergoes oxidation, and what happened to the copper? Copper undergoes reduction. So, look at the cell, when oxidation and reduction is occurring at the same time, we can call it as what? It is a redox reaction, only that much. So, this is the Daniell cell, and we are going to write the separate reaction for oxidation and reduction. Okay. what is happening to zinc? Zinc undergoes oxidation. Oxidation means increase in the charge, right? So zinc is changed into Zn2 plus. Zn changed into Zn2 plus. How oxidation? In the beginning we discussed about oxidation, right? In the beginning we discussed about oxidation, the loss of electrons. So zinc 0 is changing into zinc 2 plus by losing how many electrons? By 2 electrons. So this reaction indicates the oxidation half reaction. Okay, oxidation half reaction. Oxidation half reaction. Now we are going to write the reduction half reaction. Okay, so Cu2 plus is changed into Cu0 by adding 2 electrons. We know that addition of electrons, the charge become reduced. Okay, so Cu2 plus 2 electron gives Cu0. So what happens here? It undergoes reduction. So that is known as reduction half reaction. Reduction half reaction. Now we are going to combine, add the reactions. You know how to add the reaction? We are adding the first reaction and second reaction. If anything is coming similar in the opposite side, we can cut it. Okay, so anything is coming similar here. Any quantity is coming similar, just look at the opposite only, we can cut. Okay, zinc, copper, anything we cannot cut, right? Here, see, 2 electrons that we can cut. Now, Gibbs, write the Gibbs first. Coming in the left side, write it here. Zinc is there. Then, what is coming in the left side here? Cu2 plus, that is over. Now write the right side. Right side, what is the Zn2 plus Cu0. Look here, Zn0 changed to Zn2 plus, copper 2 plus changed into copper 0. So that happens, the complete redox reaction, that is oxidation and reduction, occurred at the same time. Okay, so oxidation and reduction occurring at the same time is known as what? Redox reaction. So this is the representation of our Daniell cell. Okay, now we are going to learn about the cell representation, how we can represent the cell. We have drawn the diagram, right? So this is very difficult to draw it completely, right? So there is an easy method to represent the cell, that is known as cell representation. What is it? Cell representation. For cell representation, this is asked for 1 mark many times for your boards. So repeatedly asked 1 mark question, cell representation. First we will write anode. This double arrow indicate salt bridge. Then cathode. So can we start? So in the anode, what we took? Zinc, right? In the anode it was zinc. Zinc changed into what? Zn2 plus. In cathode it was copper 2 plus changed into Cu0. So for that thing we are going to represent the cell. So first write the anode. Anode it was Zn. Zn changed into Zn2 plus. So how to write? Zn bar Zn2 plus. Now draw the salt bridge. 2 bar. 2 lines. Okay. Zn bar Zn2 plus is the anode. Then draw the salt bridge. Then the next one is cathode. Cathode we can draw like what is happening here? Copper 2 plus bar copper. Copper 2 plus is changed into copper. So this is the cell, not shell. We are not studying about shell. We are studying about the cell representation, the battery that we are making, right? The chemical energy is converted into electrical energy that we are using in our daily life, right? Okay, yes, anode and oxidation, cathode reduction. So anode oxidation we wrote zinc changed into second 2 plus, that is oxidation, and copper changed into copper 0, that is reduction. So in between them, mark a salt bridge. This is the correct representation. So instead of drawing, we can write like this, cell representation. From this we will get an idea which is undergoing oxidation. Zinc is undergoing oxidation, then a salt bridge is there, copper is undergoing reduction. So got it? This is very, very important. Okay, clear? So cell representation is over. Now, so if there are 2 cells, one is negative and other is positive, right? So surely there will happen a change in the potential. So the change in potential is known as what? Electrode potential. 2 electrodes are there. One is zinc electrode and other is what? Copper electrode. We immersed 2 electrodes in the picture, right? One is zinc electrode and the other is copper electrode. So these 2 electrons are having a difference in the potential, electric potential. The difference in electric potential, how we will calculate the difference in the electric potential? The difference in the electrode potential is given by the equation the difference in the electrode potential is given by the equation E cell, EMF. Okay, Saalbridge function to connect the two solutions. Two solutions are there. No, for the connection, for connecting the, maintaining the equilibrium, we are connecting it with the Saalbridge. Okay, so E cell is the change in the potential between the two electrode that is given by electrode potential of cathode minus electrode potential of anode. So EMF is given by the EMF of the cell is given by E cell is equal to E cathode minus E anode. Why we are taking cathode here? Because cathode is positive, anode is negative. So first write the positive, then write the negative. So the difference in the potential, there is a difference between the potential of cathode and anode, and it is calculated by the equation E cell, EMF of the cell, and EMF of the cell is given by E cell is equal to E cathode minus E anode, or we can rewrite it as like E right minus E left. Right side is cathode, left side is what? Anode. So positive value minus negative value. And for Daniell cell, the value is already proved. The value of Daniell cell is what? 1.1 volt is the voltage. E cell value of Daniell cell. So it will be asked for 1 mark. It is very, very important. For Daniell cell, the voltage is what? 1.1 volt. Clear? Okay. Okay. Now, there are two types of conductors. We know that there are different types of conductors. And what is meant by conductor? Anything which have the ability to conduct electricity is known as what? Conductors. And there are different types of conductors. Heat conductors are there, then metallic conductors are there. So we are going to learn about first the metallic conductors or electronic conductors. Okay. And if it allows the current to pass in metallic lattice by the movement of electrons. And we already discussed that the current will flow through a substance only when the electrons are flowing. When electrons move, only the current will flow. Okay, clear? In which direction the current is flowing? Positive to negative. Negative to positive, electrons are flowing. Due to the movement of electrons, current flows through the substance. Okay, and for example, it can be copper, silver, gold, etc. Okay, so metals are there. So due to the movement of electrons, the current will flow. Then next one, there is only physical change occur by passing of current. There is only physical changes occurring by the passing of current, and it generally shows non-transfer of matter. Matter is not transferred in the metallic conductor, only the heat or the electricity is transferred. Then in the case of solution conductors, or we can write ionic conductors. In ionic conductors, for example, if you are taking NaCl, can NaCl conduct electricity? Salt? No. NaCl can conduct electricity only in two states, that is an aqueous state or molten state. So if we add water to the NaCl, it can conduct electricity. So the ionic conductors allow the passage of electricity only when it is in molten state or an aqueous state. So the movement of ions, so the electrolytes, movement of ion, that is Na plus Cl minus, the ions are required for the passage of the conduction. Okay, there is a physical as well as chemical changes occurring. There happens what? Both changes are there. In the case of metallic conductor, there is only physical change, no chemical change. But in the case of ionic conductors like NaCl solution, KCl solution, MgCl2 solution, there is happening a chemical change because of the presence of the ions. Na plus, Cl minus, H plus, OH minus, like lot of ions will be in the solution. So due to the ions, there is happening a chemical change, and it involves a transfer of matter in form of ions. So there is happening a change of matter also, because ions are produced, like Na plus is there, K plus is there, Cl minus, OH minus, H plus, like ions will be there. So in the ionic conductors, there happens the transfer of matter also, physical changes happening, chemical changes happening. But in the case of metallic conductor, that is nothing is there, only physical changes there, no chemical change, only the movement of electrons. Due to the movement of electrons, the electricity will be passed, like copper is there, iron is there, silver is there. Okay, so these are the main difference between metallic conductors and ionic conductors or electrolytic conductors. So learn, this is the main name. We want to learn ionic conductors or electrolytic conductors. Okay. Then, during the passage of current, resistance increases due to the increase in temperature. In the case of metallic conductor, what happens? The resistance increases due to the resistance increases when temperature increases. Okay, so the thermal motion of metal ions, which results in the hindrance of flow of electron, increases with increase in the temperature. flow of electron increases, hindrance of flow of electron increases with increase in the temperature, and the conducting power of metals are very high, that we know, right? The metals have the high ability to conduct electricity. Metals are good conductors of electricity. Okay, the next one. During the passage of current, resistance generally decreases and there is decrease in the degree of hydration of ions, viscosity of medium, and the conducting power of electrolytic conductors are relatively low. The conducting powers of electrolytic or ionic conductors are relatively low when compared to the metallic conductors. Okay, is that clear? Now, we are going to electrolytes and electrolysis. Electrolytic cell, but it's just the opposite. Electrical energy is converted into chemical energy, and before that very many derivations are there. First we can go to the derivation and we can come back to the electrolysis. So just we can read dilution. What is by dilution? When we are adding water to a substance, it will become diluted, right? So when current is passed through the aqueous solution of a substance and the substance decomposed into ions, then the substance is termed as electrolyte. Or simply we can tell any substance which have the ability to conduct electricity through it is known as electrolyte. It can be water, it can be acid, it can be base, anything which have the ability to conduct electricity through which is known as what? Electrolytes. Like NaCl solution, KCl solution. Got it? So that is electrolyte. Then electrolytic decomposition or electrolysis means what? The decomposition. When current is passed through that, it will decompose into ions. That is known as electrolysis. Like positive ion and negative ion will be produced. That is known as what? Electrolysis. And there are two types of electrolytes. Strong electrolyte and weak electrolyte. And electrolytes are like solution of alcohol, glycerin, cane sugar, etc. Examples of non-electrolytes. There are non-electrolytes also which doesn't have the ability to conduct electricity. They are known as non-electrolyte. Example, alcohol, glycerin, cane sugar, examples of non-electrolytes. Then base, acid, water, salt solutions are example for electrolytes. So what is electrolyte? The ability to conduct electricity through it is known as electrolyte, and it can dissociate into ions. They will be dissociating into positive and negative ions, and that process is known as what? Electrolysis, by the passage of current. Clear? So the electrical energy is converted into chemical energy in electrolysis, that is electrolytic cell. The first cell that we discussed is galvanic cell, voltaic cell, or electrochemical cell. In the electrochemical cell, chemical energy is converted into electrical energy by the means of redox reaction. Just opposite in the case of electrolytic cell. Here, the electrical energy is converted into chemical energy. Is that clear? Electrical energy is converted into chemical energy. That process is electrolytic cell. Electrolysis, where when the current is passed through the solution electrolyte, it will dissociate into cations and anions by the passage of current. And that happens a dissociation. That dissociation produces the chemical change. Chemical energy is produced. Okay? Clear? Then. So the next one is strong and weak electrolyte. When the degree of dissociation is complete, when they can dissociate completely into cations and anions, positive ions and negative ions, they are known as strong electrolytes. The first one is strong electrolyte. The substances which are largely dissociated, that means they are largely dissociated and form highly conducting liquid. They will be highly conducting liquid. All salt. Mineral acids like HCl. HCl has the highest degree of dissociation. HCl can dissociate like HCl dissociate into what? H++, Cl-. They can completely dissociate, so it will show large dissociation. So it comes under the category strong electrolyte. So what is my strong electrolyte, my dears? Strong electrolytes means the degree of dissociation will be very high, very large. Okay, then next one. The next one is other example H2SO4, then bases like KOH, NaOH, etc. are the examples for strong base. Okay, then they are almost 100% ionized in normal dilution. Then we can go to the next topic, that is weak electrolyte. In the case of weak electrolyte, the ionization, degree of ionization or dissociation will be less when compared to the strong. That they are low conducting liquid and the aqueous solution, all organic acids except sulfonic acid, inorganic acids like H3PO3, HCN, and the bases like ammonia, amines, and CH3COH, like acetic acid. They are the examples for weak electrolyte. Their conductivity will be very low when compared to the strong electrolytes. So learn these two things. That is very, very important for the examples related questions. Okay. Then factors influencing the degree of dissociation. The degree of dissociation factors are affected by nature of solute, nature of solvent we used. The solute means all ionic compounds. Strong electrolyte have approximately 1 at normal dilution. Mole polar covalent compounds have less than 1. Okay, then nature of solvent having high dielectric constant are themselves feebly ionized, but an electrolyte in high dielectric constant solvent show higher degree of dissociation than in a solvent. So these are the two factors affecting the degree of dissociation alpha. It is denoted by the letter alpha. Alpha is given by mole dissociated at any time divided by total mole present at time equal to 0, or dissolved initially. Initial number of moles, total mole dissociated at any time divided by initial number of moles. Okay, clear? Got it? Okay. Then next one, it will depend on dilution, temperature. When temperature increases, what happens to dissociation? Dissociation also increases. So increase in the temperature affects the dissociation also. Then addition of other species affects the dissociation. So electrical energy is converted into chemical energy, and chemical energy is converted into electrical energy. That is the main topic that we are going to discuss in this chapter, right? So electrolytic cell or voltaic cell, that we already discussed, the Daniell cell. It is also known as like what? Electrochemical cell, Daniell cell, galvanic cell, voltaic cell. Now we are going to discuss about the electrolytic cell, voltmeter or voltmeter, like that. Okay. The device which carries the process of electrolysis, just opposite that we learned the beginning, just opposite. What is opposite? Chemical energy converted into electrical energy, but in the case of electrolytic cell, what is happening here? Electrical energy, I am writing like EE, okay, electrical converted into chemical. Electrical energy converted into chemical energy is known as electrolytic cell or voltmeter, and voltmeter convert the electrical energy into chemical energy. So learn the main word, that is electrolytic cell, in which electrical energy is converted into chemical energy. Is that clear? Got it? Then anions are discharged on anode and cations on cathode during the electrolysis in voltmeter. In voltmeter, flow of electrons is from the anode to cathode, and the current will flow from cathode to anode outside the electrolyte. So E cell is equal to negative, delta G is equal to positive for voltmeter. Then application of electrolysis. Before that, I will show you the diagram of electrolysis. So we will take a beaker. Very important. Here we will be filling it with a solution that we want to do the electrolysis, and 2 rods will be dipped in the same beaker. 2 rods will be dipped in the same beaker. Okay. Now in this liquid, it is immersed in a liquid, and this will be NaCl. We can take NaCl solution. NaCl solution. Okay. Clear? NaCl solution. And these 2 rods are connected to battery. So this is positive, this is negative, and we know that in the case of Daniell cell or electrochemical cell, anode is negative, cathode is positive. But in the case of this electrolytic cell, electrolysis, anode will be positive. Here, anode is positive, anode positive, cathode will be negative, just opposite of what? Electrochemical cell. Learn it, which is very important in electrolysis. Okay, in electrolysis, anode is positive, cathode is negative, just opposite. So, for example, this is very important. Listen carefully. We are going to take NaCl solution. NaCl solution means what? Na plus. NaCl means what? This is our beaker. Okay. Na will be there, Cl will be there, hydrogen, OH. Why HOH? H2O can be split and written as H and OH, right? NaCl can be written as Na and Cl. Na and Cl. Okay. Now, when the current passes, electricity is passing from here, right? When the current flows through the solution, what will happen? It undergoes dissociation. Complete dissociation will happen. When electricity passes through the solution, it undergoes dissociation. So dissociation, how will the dissociation happen? NaCl will be dissociated into plus and minus. Na cations and Cl anions. Na plus plus Cl minus. So like this, Na plus Cl minus. What will happen to the water? H plus OH minus. And we learned in the lower class itself, negative attracts positive, positive attract negative. So after the dissociation, when the electricity passes, the positive ions attract the cathode. The positive ions are known as what, my dears? Positive ions are known as cation. So out of this 4, which are the positive ions? Na plus and hydrogen, right? These two are positive ions, and the positive attracts the cathode. Okay, and the ions are known as what? Cations. So cations attract cathode because cations are positively charged. So it will be deposited on the cathode. Cathode is negative. Similarly, here Cl minus OH minus is there. They are negatively charged. They will be deposited on the anode, and the negatively charged ions are known as what? Anions. Anions are negatively charged. Anions negative, cations positive. So two types of ions are produced when the electricity is passed through the solution, that is anions and cations. Anions attract the anode, anode positive. Cations attract the cathode. Cathode is what? Cathode is negative. Cation positive, anion negative. Now, one more thing. Anode will undergo what? Anode will undergo oxidation. Anode will undergo oxidation, and cathode will undergo reduction. There is no change like the electrochemical cell. That is same. Okay. Anode undergo oxidation, cathode undergo reduction. Okay, clear? Got it? Now, when we compare the oxidation capacity, chlorine is having more oxidation capacity. OH is not having that much oxidation capacity. So the OH will come back to the beaker. So OH will be here. OH minus. Then here, when we compare the reduction capacity, sodium and hydrogen, sodium is the more reactive one, no? So it will undergo oxidation only. So sodium also will come back to the beaker. So it will be coming back to the beaker, Na plus. Cl will go there. Hydrogen will be going to cathode. Cl will be going to anode. Now, what is remaining there in the beaker? NaOH. They will combine. Na plus and OH minus will combine together to form sodium hydroxide solution in that beaker. So this is the process of electrolysis. In electrolysis, chlorine is added to the anode. Deposited chlorine gas will be liberated at the anode, and hydrogen gas will be liberated at the cathode. Positive attract the negative, that is cations attracted towards cathode. Negative anions attracted towards anode. Clear? Got it? Okay. Then next process, it's an easy process. What is electroplating? We can use the electrolysis, an application of electrolysis, that is electroplating. Electroplating is a process of coating one metal over the other metal by the help of what? Electricity. Using electricity, we can coat one metal over the other metal that we are using, right? We are using many utensils, many fancy ornaments. How it is produced? Like rolled gold ornaments are there? No. By covering one metal with other metal. That process is known as electroplating. Here, we are using electricity. By the means of electrolysis, we are coating. Instead of superior, you can use coating one metal over another metal. Okay. Coating one metal over other metal. Coating one metal over other metal by electrolysis is known as electroplating. Okay. So, for example, if you want to coat gold on iron, the gold will be connected to the positive terminal and the iron will be connected to the negative terminal of battery, and it will be carrying out the electrolysis. So, we can coat the gold over the iron bangle. That is an example for electrolysis. Is that clear? Understood, everyone? If you have any doubt, you can ask in the comment section. We can clear the doubts and we can move forward. Okay. So, we are going to the law session. First law is Faraday, you are familiar with Faraday, right? The first law is what? The Faraday's law of electrolysis. These laws are given by Michael Faraday in 1833, and the Faraday's law of electrolysis governs that during the process of electrolysis, the substance are deposited on electrodes. That we learned now, right? I have showed you the attraction. For example, if beaker is there, anode will be there, cathode will be there. Cathode is negative, anode is positive. Here, when electricity passes, what will happen? Negative ions attract anode, positive ion attracts cathode, and negative ions are known as anions and positives are known as cations that we discussed. The same thing that we is going to explain by the Faraday, that is what? The electrodes, on the electrodes, substances are deposited on anode and cathode. Okay. So which ions are deposited on anode? There are anions and the cations are deposited on cathodes. Clear? Any doubt? Okay. So we are going to the first law of Faraday. This is very important, and they will ask like, simply state the Faraday's first law. Is a previous year question, PYQ question. Faraday's first law. The Faraday's first law stated that the mass of any substance deposited or liberated in any electrode is directly proportional to the quantity of electricity passed, right? When we are passing electricity from the battery to the electrodes, when electricity is passed, what will happen? English में बोलो. So English class, okay, we'll be dealing with in English class, not in Odia, and I don't know Odia also. Okay. Okay, come back. So that is very easy. The first law is very easy. We know that when electricity passes, what happened? The substance will be deposited on the electrode, anode and cathode, and they are directly proportional. When more quantity of electricity is passed, what will happen? The deposition also increases, so that it's directly proportional. That means the mass of any substance deposited on any one of the electrode. Okay. The mass of any substance deposited on any one of the electrode is directly proportional to the quantity of electricity passed, where W is directly proportional to Q. W means the mass, where W means the mass of the ions. W is, or instead W we can write M also, no problem. W directly proportional to Q, where Q is the quantity of electricity, and we can change like current in ampere into time in second. W proportional to Q, where Q we can write like charge into current in ampere. Current in ampere into time. This is the equation for charge. Learn the equation. Q equal to what? The quantity of electricity in coulombs, that is I into T. I is the current and T is the time in second. So what will be the change in equation? W equal to set IT. W equal to, remove the proportionality using the constant set. Then Q is what? IT. So this is the final equation for the first law. Very important equation. W equal to set IT. Okay. And in case of current efficiency eta, we can write the equation like W equal to set IT into eta by 100 for the current efficiency. Note this equation also, but this is the main equation. W equal to set IT, where set is the proportionality constant, I is the current, and T is the time in second. Okay. Is that clear? Yes, we can do the exercise questions also. After the one shot, we will be doing with the exercises also. Okay. Clear? Then, next one set is a constant called electrochemical equivalent of the ion deposited. That is very important. Set is a constant. When current 1 ampere is passed for 1 second, what will be the equation? W equal to set IT when current equal to 1. When current equal to 1 and time equal to 1 second. So what will be the W, the mass deposited? The mass deposited will be equal to how much? Z into 1 into 1. That means the answer will be equal to W equal to Z. Okay. Then we are going to the second law. The first law is clear. The mass of the ions deposited will be directly proportional to the quantity of electricity passed. That is the first law. Okay. Then the next law, we are going to the second law. The second law, when the same quantity of electricity is passed through different electrolytes, the mass of different ions liberated at the electrodes are directly proportional to their chemical equivalent weight. Chemical equivalence. That means if we are passing electricity, the same electricity we are passing through different two electrolytes is the same. The mass of ions deposited will be same? No, it will depend upon the chemical weight of the hello, hi. So it will depend upon the what? It will depend upon the chemical equivalent weights of the electrolyte that we use. That is a second law. When the same quantity of electricity is passed through different electrolyte, the mass of different ions liberated or at the electrodes are directly proportional to their chemical equivalence. equation W1 by W2 equal to E1 by E2, or this equation is not required, actually just read it, okay. Therefore, electrochemical equivalence of an element is directly proportional to the equivalent weight. This one is required. This is the main equation, E directly proportional to Z, where E equal to Fz, where F is the Faraday's constant, 96500, okay, Faraday's constant, okay, is that clear? So learn this final equation and the Faraday's second law. Now we are going to the easiest terms that we learned in physics, that is resistance, conductance, conductivity, resistivity. Okay, are you ready? Are you ready, right? Sorry, this class will be completely in English, not in Marathi or Hindi. This is pure English class, okay? Yes, we will summarize it again, okay? Again, it will be coming Faraday's law, then we will summarize it. Okay, so we are going to the next topic, that is electrical resistance and conductance, that we are familiar in the physics also. What is resistance, what is conductance, right? So, resistance and conductance. First one is resistance. For example, resistance is denoted by the letter R. Resistance means what? The hindrance offered to the flow of current is known as what? Resistance, right? Okay, hello. Okay. So, resistance is the hindrance offered to the flow of the current. So, it is denoted by the letter R, and according to the Ohm's law, we know the equation R equal to V by I. R equal to what? V by I. In the ohms. Okay, then conductance is the opposite of resistance, and conductance is the opposite of resistance. Conductance is the opposite of resistance, so we can write like it is a reciprocal of resistance, though G is given by 1 by R. Resistance is what? V by I, and it is conductance is just the reciprocal of the resistance, and we can write like 1 by R. Conductance is equal to 1 by R, and it is the conductance is the ability of the material to conduct the electricity, right? Which of is the favors the flow of current, and the unit will be what? A resistance unit is ohm. Conductance unit is ohm raised to -1, because it is reciprocal. No, ohm raised to -1, or opposite, mho. Mho is the unit of conductance. Okay, mho is the unit of conductance. So resistance is there, conductance is there. Next one, we are going to learn about the specific resistance, resistivity, and the resistance R of a conductor is directly proportional to the length. So come back, we are going to do a derivation. It is very important to learn about the resistance, resistivity, conductance, conductivity. And for a material, resistance is directly proportional to the length. First equation, okay. Resistance is directly proportional to length and inversely proportional to the area of the conductor. For example, if you are taking a wire, look at the wire here. According to the length of the wire, the resistance increases, and according to the area, resistance decreases. That means resistance is directly proportional to the length of the conductor that we are using. Okay. Resistance is directly proportional to the length and inversely proportional to the area, where we will write the inversely proportional down. Inversely proportional to area. Now we want to remove the proportionality constant. So to remove the proportionality constant, we are introducing a constant. We are introducing a constant, that is rho. Rho L by A is the equation for resistance. What is rho? Rho is the proportionality constant known as resistivity. Okay. Rho is the proportionality. Rho is the proportionality constant, resistivity. Clear? So that is given here. R equal to rho L by A. Now we are going to make an equation for rho. Okay. So R equal to what? We got R equal to rho L by A. Now we want an equation for rho. So take all other terms to the left side. Take A here. So it will become R A L to the opposite side divided by L. So what is the equation for rho? Rho is equal to RA by L, where RA by L, rho is known as the resistivity. R is resistance, rho is resistivity. Is that clear? Resistivity. Now we are going to write the unit. Resistance unit is ohm, or We know it is ohm. Resistivity unit we are going to write, okay. R unit is ohm. Area unit is meter square. Length unit is meter. So cut the meter square. So what is remaining there? Ohm meter is the unit of resistivity. Very, very important. Note it, the unit of resistivity is what? Ohm meter. Clear? Any doubt? Ohm meter. Then next one is conductance or specific conductivity, conductance and conductivity K. The conductivity is defined as the reciprocal of specific resistance, that is K equal to, first we learned about G, right? What was G? G equal to reciprocal of R, resistance reciprocal, that is conductance. Conductance is G, and what is the unit of conductance? Unit is given by 1 by ohm, or we can write like 1 by ohm. When we take the denominator to the numerator, it will become ohm raised to minus 1 or ohm inverse is the unit of what? Conductance G. Okay, now we are going to learn about the conductivity. Conductivity, the same equation we are going to take. Conductivity is represented by the letter K, kappa. What is it? Kappa. And it is a reciprocal of resistivity, 1 by rho. K equal to the conductivity. Conductivity is given by the letter K, kappa. Kappa is equal to 1 by rho. And we know the equation for rho, right? What is rho? Rho equal to RA by L. Just substitute the rho here. So it will turn like 1 by RA by L. So take the reciprocal, L by, what is it? L by RA. Okay, L by RA is the equation for kappa K. L by RA is the equation for kappa K. And specific conductance is equal to conductance into cell constant. Again, we are going to a derivation, that is, what is 1 by R? Here, look at here. Kappa, we got kappa equal to 1 into L by R into A is the final equation. No, we know that again the substitution 1 by R. What is 1 by R? 1 by R is a reciprocal, right? Reciprocal of resistance is what? Conductance. So we can replace the 1 by R using G into L by A. What is L by A? G into L by A. So kappa equal to G into L by A. Clear? Any doubt here? Boats. For boats. Not for JE, for boats. Okay. So, what is the final equation for kappa? The conductivity can be given by conductance into L by A is the final equation, and it can be given, the specific conductance is equal to conductance into cell constant. Cell constant is given by G into G star. So, we can represent the L by A by G star, L by A equal to G star. So, K equal to G into G star. K equal to what? We got final equation like 1 by R into L by A, where 1 by R equal to what? G, and L by A is a cell constant G star. G into G star is the another equation for our conductivity K, G into G star. Clear? Then here it is given G into G star. G star is equal to L by A, unit is centimeter raised to minus 1. So these equations are very, very important. I will mark the main equation 1. Then second one, third one, and the fourth one. These are very, very equation related to the conductance and conductivity. Learn it. It will be very useful for your final exams. Okay. Molar conductivity is given by the equation K into V and K into 1000 by M, the volume in liters. So it is converted into 1000 by M. D by Huckel's on-site equation, we can come to that. Before we want to learn about the Kohlrausch's law of independent migration. Kohlrausch's law of independent migration. You know what is Kohlrausch's law of independent migration, my dears? What is Kohlrausch's law? Kohlrausch's law of independent migration of ions means the dilution, when dissociation is complete, every ion makes some definite contributions towards the molar conductance regardless of the nature of their ion. That means there will be the individual, the ions dissociation we will be calculating by the sum of the dissociation of the individual ion, that is cations and anions. Okay. You can download the notes by one link is given in the description. You can check the link and you can enter to that app and you will be getting the notes. Okay. Okay. So the law is stated that for an electrolyte, the sum of contribution of the individual ions, the total dissociation is given by the sum of the individual ions. Dissociation of the individual ions, that is given by, for example, it's very easy to learn. Total molar conductivity, lambda m is equal to lambda plus plus lambda minus, that is plus ions plus minus ions. For example, we have NaCl. How the NaCl is dissociated? NaCl is dissociated as Na plus plus Cl minus. So how we will calculate the molar conductivity? How it is dissociated? Na plus and minus Cl minus, right? So we can calculate the dissociation by, according to the Kohlrausch's law, the total lambda NaCl is given by lambda Na plus plus lambda Cl minus, that is cations plus anions. Very easy one. Okay, so we can calculate the total that independent migration. According to the law of independent migration, it will be equal to the sum of the dissociation of individual ions, cations and anions, that is lambda Na plus plus Cl minus. Is that clear? Okay. Then determination of a lambda m, that is molar conductivity of a weak electrolyte. For example, we are having acetic acid, ethanoic acid, CH3COH. And how we will calculate the dissociation? Lambda m, molar conductivity. How we will calculate? For that purpose, we are taking HCl, CH3CO, Na. Minus, here one lambda m is there, okay, lambda m, this is a previous question for you. I have added a question here, look here, lambda m HCl plus lambda m0 CH3CO Na minus NaCl. So how we will write here? Here, first one is HCl. This is a question, determine the molar conductivity of the weak electrolyte acetic acid. For this question, we want to write the HCl. For HCl, we can write like lambda H plus Cl minus, how we will write? Lambda Cl minus. So HCl is over. Then plus. Next one is CH3CONA. CH3COONA. The dissociation will be like how? CH3 lambda CH3 COO minus plus lambda Na plus. Then minus. Next one is, look at the sign, it is minus NaCl. How will write NaCl? Lambda Na plus plus. When we take the minus to the inside, it will change to minus. So lambda Cl minus. So we can cancel Na plus Cl minus Cl minus. So what is remaining there? CH3 COO minus is there and H plus is there. So together they will make the total CH3COOH. So this is the method to calculate the molar conductivity using limiting molar conductivity using the Kohlrausch's law of independent migration. So sum of the molar conductivity of the individual ions will give the total molar limiting molar conductivity, lambda m0. Is that clear? Any doubt? Okay. Okay, done. So we can go to the next topic. And determination of the degree of dissociation is given by the equation alpha equal to the number of molecules ionized divided by the total of number of molecules dissolved. So alpha is equal to the degree of dissociation ones that we already discussed. Alpha equal to given by the equation lambda m divided by lambda 0. That is total number of molecules ionized by the total number of molecules dissolved is given by the determination of degree of dissociation. And the factors affecting electrolytic conductance. And which are the factors affecting electrolytic conductance? It can be asked for 2 marks or 1 mark as a sub question. The factors affecting are the inter-ionic attraction. The attraction between ions are more. What will happen? The conductance will be less. there should be free ions, like positive and negative ions should be free, then only it can easily conduct electricity through the solution. For that purpose, the interionic attraction should be very weak, then only it can conduct. If the attraction is very high, what will happen? It cannot change it to ions, positive and negative ions, it cannot change. So what will happen? What will happen? The conductivity will decrease, the conductance will be very low. Note the point, when the interionic attractions are very high, the conductance will decrease. The next one is polarity of the solvent. If solvent was high, dielectric constant, then the ionization and conductance will be higher. Okay, polarity. If the polarity is very high, what will happen to the conductance? The conductance will be very, very high. Alpha, beta, gamma. Where we are using the alpha, beta, gamma? Alpha is the degree of dissociation, okay? Then next one, viscosity of the medium. On increasing the viscosity of the medium, the conductance decreases. Viscosity, we know the force of attraction between the molecule is very high. What will happen? The conductance will decrease. The temperature increases, conductance increases. That is very, very important point that we need to give importance for the temperature. Temperature increases, what will happen? The conductance also increases. So these are the factors affecting the electrolytic conductance. Now we are going to the next one, dilution. Dilution is also important. Dilution increases, the conductance increases, D increases. Why? Dilution increases means, for example, if we are diluting an acid solution, we are diluting anything, we are adding water. So when we increase the dilution, the concentration decreases, right? So when dilution increases, the conductance increases. For a strong electrolyte, dilution, the force of attraction decreases, right? The force of attraction between the ions and the molecules decreases when we are diluting it. So when dilution increases, the force of attraction decreases. So therefore, the conductance increases in the case of strong electrolyte. For weak electrolyte, the degree of dissociation, dilution increases, therefore conductance also increases. For both case, dilution increases the conductance. That point is very, very important. So representation of a cell, we already represented it now. In the beginning itself, we represented, just recall it. How we will represent? First we will represent the anode, then the salt bridge, then we will represent the cathode. Zinc 2 plus, salt bridge, then what will you represent again? Cu2 plus Cu. Zinc undergoes oxidation, that is the anode, and copper undergoes reduction, that is the cathode. In between them, we will mark the salt bridge to show the differentiation. So this is the representation. This will be asked for 1 mark question. For 1 mark, it will be asked for your PYQ. It's an important question. Noted the cell representation. Okay, clear? Then we are going to the next one. Net reaction. This also we discuss how we will write the net reaction. Net reaction can be written as oxidation. Oxidation, reduction, oxidation plus reduction. We will get the total reaction, the total redox reaction. Oxidation half cell plus reduction half cell. It will form what? The total redox reaction. Then the next one, electrode potential. How we will calculate the electrode potential? These are the summary of the topics that we already covered. Okay. So how we will calculate the electrode potential? Electrode potential can be calculated using the difference between cathode and anode. E cell is equal to, what is electrode potential? Metal acquires a negative or a positive charge with respect to the solution when it is placed. That we know. Anode is negative, cathode is positive. So there happens a difference in the potential by the definite potential developed between metal and the solution. There is a potential between, already there will be a potential difference between, for example, 2 beakers are there, no. 2 beakers are there, here one metal is placed, here also one metal is placed, one solution is there, solution is there. So there is a potential difference between this metal and the solution. This metal and the solution, there is a potential difference. That is known as what? The difference in the potential is known as what? The electrode potential. It depends upon the concentration of ions, the nature of electrode and the temperature. Okay, clear? Then this thing is not required actually. Then salt bridge construction, that we know, it's an inverted U-shaped tube, contains inert electrolyte like KCl, KNO3, and you asked what is a salt bridge. This is the answer for the salt bridge. Salt bridge is like inverted U tube. It is like an inverted U tube that connects the 2 beakers, and it is filled with inert electrolytes like KCl, KNO3, NH4Cl, etc. or agar gel and gelatin. And ions of electrolyte do not react with the ions of electrode solution. These ions won't react with the electrode solution. It will be present only inside the salt bridge. Okay, then next one. What is the function of the salt bridge? To complete the circuit, to complete the electrical neutrality, that is the main point. What is the function of the salt bridge? To complete the circuit and to maintain the electrical neutrality, we are adding a salt bridge in the circuit. Okay, clear? Okay. Next one is a standard reduction potential, very, very important. Standard reduction potential, and if we don't know the potential of one electrode, what we will do? In the place of that electrode, there is a difference between the potential, right? What is the difference in the potential? E cell, how will we calculate the E cell? E cell is equal to the change in the potential of cathode and anode. E cathode minus E anode, or E right minus E left is given by the E cell. And if it is standard, for example, if we don't know the potential of one electrode, what we will do? In the place of that electrode, we will kept an imaginary, that is made by She, hydrogen electrode. Standard hydrogen electrode we will be using, and it is always constant value for the She, and we will be using the She and we will be calculating the potential of the other one. Conditions according to the IUPAC convention, standard electrode potential, reduction potential equal to standard. Okay, then cell potential or EMF of the cell. How we will calculate the cell potential or EMF? What is OP? Oxidation, reduction, that is RPOP. Okay, the difference between the electrode potential of two half cell is known as cell potential. What is the equation? And this is very, very important. That's why I am repeatedly giving the slides. E cell is equal to E cathode minus, why first cathode? Because cathode is positive, that's why we are minusing it from cathode. E cathode minus E anode. Now we will be getting the cell potential. This means the potential difference between the two half cells. Okay, clear? Then relationship between Gibbs free energy change and EMF of a cell, and that equation is very, very important, and this you need to learn the relationship between Gibbs energy and the EMF of the cell. And the equation is given by, we know that the Faraday's equation, Q equal to N into F. What is Q? Charge is equal to N into F. N is the number of electron and F is the Faraday, and we are going to substitute in this equation delta G, Gibbs energy. The change in the Gibbs energy is given by minus NFE cell. And many questions are asked from this section, this related to this equation. How we will calculate the Gibbs energy related to the E cell, or the relationship between Gibbs energy, free energy, and the change of EMF. Delta G is given by delta G equal to what? Minus NFE cell. Minus NFE cell. Very, very important equation. Note it. Then next one, spontaneous, non-spontaneous equilibrium. And we know that for a spontaneous process, the delta G will be what? Negative, that we learn in class 11. And for a spontaneous process, the Gibbs energy change will be negative. For a non-spontaneous process, it is positive. Equilibrium, no change, it will be 0. Then what happened to the C? For a spontaneous process, it will be positive. Non-spontaneous, it will be negative, and at equilibrium, it will be 0. So learn this table. That's just for your information. It can be asked for 1 mark, the signs. Okay. Then electrochemical series, we know what is electrochemical series. The elements arranged in the decreasing order of their reduction potential. The elements arranged in the decreasing order of their reduction potential is known as electrochemical series. In our textbook, one table is given in one whole page and representing their electrode potential. For example, I will give you one question. Try to solve the question. The potential of, I'm going to give the simplest one. Zinc, I will give you. The potential of zinc is minus 0.76 volt, and this is zinc. Okay, zinc potential is minus 0.76 volt, and copper is 0.34. How we will calculate the cell, E cell? How we will calculate the E cell? Can anyone give the answer? Two potential are given here. Zinc potential and copper potential are here. Zinc potential, zinc electrode potential is given by minus 0.76 and copper is 0.34. We can calculate the value. We know the equation. How to calculate the cell? E cell is equal to E cathode minus E anode, and the potential is given like zinc is minus 0.76 volt and copper is 0.34. So substitute in this equation only that much. How will we be substituting? Cathode is, who is the cathode here? Copper, 3.14. minus 0.76. So minus will become positive. So the answer will be 0.34 plus 0.76. It will be changing into the value 1.1 volt is the final answer for the potential. And if a cell is made up of copper and zinc electrode, it is known as what? Daniell cell. So Daniell cell is made up of zinc and copper. The potential is given. Copper is cathode and zinc is anode. Copper potential minus zinc potential. So the total answer will be 1.1. So it's a Daniell cell. So learn the value of Daniell cell. It is 1.1 volt. Okay. Then we are going to the derivation session, that is Nernst equation. Nernst equation is very, very important. How we will find the Nernst equation? Nernst equation is used when the concentration is not equal to 1 molar, then we will use the Nernst equation. When the concentration is not equal to 1 molar, we will use the term what? Nernst equation. And according to the thermodynamics, delta G equal to delta G0, RT log Q, ln Q. Okay. And one more equation, I will give you the relationship between delta G equal to minus RT ln Q. Learn this also, okay. So before that, I will give you the derivation for Nernst equation. When you look at the slide, it won't be clear for you. Nernst equation is given by, first one, for example, we are taking the E cell is the cell potential. Okay, we are taking the Daniell cell made up of zinc and copper. Okay, first we are writing the potential of copper. So how we will write the potential of copper? For that purpose, we are taking the equation. The cell potential is given by E cell is equal to E0 cell minus E cell is equal to E0 cell minus RT log oxidized So this is the equation for oxidize. How to write? E cell is equal to E0 cell minus RT ln oxidize by NF. Oxidize means here I am taking certain because it is certain is the oxidized one, certain is the anode. Now it is given in natural logarithm ln. We need to convert into log. So how we will do that? What is E0 cell? E0 cell is the standard electrode potential. What will be the equation for standard electrode potential? E cell we know. So E0 cell will be what? E0 cell is equal to E0 cathode minus E0 anode. Okay. E0 cathode minus E0 anode. Now, I'm going to remove the ln by using the term 2.303 RT minus 2.303 RT by NF log 1 by Zn 2 plus. So, this is the equation for our zinc equation, Zn. Okay. Now we are going to make an equation for copper. For the case of copper, what will be the equation? E cell is equal to E0 cell minus similarly 2.303 RT by NF into log 1 by Cu 2 plus. So these are the two equations. Now the final equation is given by E cell is equal to E0 cell, that is cathode minus anode. What is E cell? E cell is equal to E cathode minus E anode, and we are going to substitute the equation. E cathode is given by copper and E anode is given by zinc. So first we are going to write the equation of E cathode, that is E0 Cu2 plus bar Cu minus 2.303 RT by NF means 2 into F, 2F log 1 by Cu2 plus. Then whole minus is there, minus, I'm going to put a bracket here, big bracket, then E0 Zn 2 plus bar Zn minus 2.303 RT 2F log 1 by Zn2 plus. So these are the equation. Now we are going to open the bracket. When we open the bracket, write the similar terms together. So E0 copper and E0 Zn I'm going to write together. That is E0 Cu2 plus bar Cu minus E0 Zn2 plus bar Zn. Then whole. Then two common terms are there. Minus 2.303 RT by 2F log A minus log B. What is log A minus log B? Log A by B, right? Log A minus log B is what? Log A by B. Now, when we take the recipe A by B, when we write A by B, zinc will go to the numerator, copper will come to the denominator. So, this is the final equation. What is it? Log Zn 2 plus by copper 2 plus, oxidized by reduced. It's not over. No. What is E0 cathode minus E0 anode? We know E0 cathode minus E0 anode is equal to E0 cell. So, we are calculating the cell potential is equal to standard electrode potential minus. Now, when we substitute the value of R, universal gas constant, temperature and Faraday, 96500, and it will be equal to the value 0.059 divided by 2 log, writing the general equation, oxidized by reduced. This is the final Nernst equation. Very, very important. So, what is the Nernst equation? E cell is equal to Nernst equation. So, the Nernst equation is, so the Nernst equation will change into E cell is equal to E0 cell. What is E0 cell? The standard electrode potential. E0 cell minus 0.059. How we got the value 0.059? By multiplicating 2.303 into R into T divided by the Faraday. That is 0.059 whole divided by the number of electrons, it is 2 for the equation, or we can simply generalize the equation N. Generally, N will be the number of electrons. Then, what is remaining there? Log. On the numerator, it will be oxidized, which is the oxidized term. For example, it will be zinc, then reduced. Under it will be reduced one. So, this is the final equation for the Nernst equation. So, what is the Nernst equation? E cell is equal to E0 cell minus 0.059 divided by N log oxidized by reduced. Clear? Now, I will give you another equation, that is copper plus 2 AgNO3 gives CuNO3 twice plus 2Ag. This is another redox reaction that we already done the calculation of oxidation and reduction. Here copper undergoes what? Copper 0, it will change to plus 2, and silver is plus 1, here it will change to 0. Silver is undergoing reduction. So, can we write the Nernst equation for this equation? Can we write it? It's very easy thing, right? So, how we will write? E cell is equal to E0 what? Who is undergoing oxidation and who is undergoing reduction here? E0 silver minus E0 copper. Okay. E0 silver, that is E0 cell, minus 0.059 divided by the number of electrons, it is 2. Then remaining log. On the top, who will be coming? Undergoing oxidation is copper 2 plus divided by Ag plus. But how many Ags we wrote here? To balance, we wrote 2 there. So, raised to term 2. Ag raised to 2. Okay, Saloni? So, Ag raised to 2 will be the answer. So, this is a representation of this cell's Nernst equation. Okay, clear? Any doubt? Then, application of the Nernst equation. What are the application? To calculate the electrode potential. That's the main application that we already discussed. Okay, the application of Nernst equation. They calculate the electrode potential. E0 cell. We can calculate it. The next one is, then we can calculate the electrode potential and pH of any hydrogen electrode. That is She. What is She? If we don't know the potential of one electrode, we can use a hydrogen electrode made up of platinum and hydrogen gas. Okay. And this is very, very important, the calculation of equilibrium constant Kc. Using this Nernst equation, we can calculate the equilibrium constant Kc or Kc. Instead of K equilibrium, we can write Kc. For example, E cell. At equilibrium, E cell value will be equal to, at equilibrium, E cell will be equal to 0. So, what will be the change in the equation? E cell equal to E0 cell. Remaining thing, what is remaining thing? 0.059 divided by N. Log Kc. Okay, at Kc the oxidized by reduced will be equal to Kc. Okay, at equilibrium, this one, at equilibrium oxidized by reduced will be equal to Kc. So instead of the oxidized by reduced, we can simply substitute Kc. And we know that at equilibrium, this value will be equal to 0. E0 cell is equal to 0. So we can change the equation. Here it will be 0. Take E0 cell to the opposite side. So E0 cell is equal to, what is the change? 0.059 divided by N. Log Kc is the final equation when it is at the equilibrium. E cell is equal to what? 0. Okay. Now, delta G equal to, we already wrote one equation. We can calculate delta G by delta G. 0 Gibbs energy changes equal to minus RT ln Kc. So, if ln we don't know, we can remove it by the term minus 2.303 RT log Kc is the equilibrium used for another calculation for the Gibbs energy. So there will be two equations for the Gibbs energy. One is this one, and the other is minus NFE. Okay. Then concentration cell, electrode potential. Electrode gas concentration cell, that is She, made up of She. If we don't know the one electrode, we can use what? She, standard hydrogen electrode. Standard hydrogen electrode can be asked for 1 mark. Okay. Standard hydrogen electrode, and is made up of platinum. Hydrogen gas will be bubbled through it, and for spontaneous such reaction, P1 is greater than P2. Then electrolytic cell we already discussed, right? What is electrolytic cell? The electrical energy is converted into chemical energy with the help of electricity. Chemical energy is produced. So in the same beaker we will be taking two rods. The positive will be there, negative will be there. Here the positive will be what? The positive will be anode, the negative will be cathode. Just the opposite of electrochemical cell. Same thing we discussed like 1 hour before. When we started the class, we already discussed and we completed everything. Again, the summary is given like electrolytic cell. Okay. This also we discussed. Faraday's law. Remember the Faraday's law? Faraday is having two laws, first law and second law. First law, what is it? The mass of the ions deposited will be directly proportional to the quantity of electricity passed. So that's the same thing as given here. W equal to Z IT was set as the proportionality constant, where I is the current and time, T is the time in seconds. So okay. So again, as for your revision, I have added the slides. We already discussed the same thing. Faraday's first law, Faraday's second law. Then second law of electrolysis is what? The substance deposited or dissolved at anode or cathode will be equivalent to their equivalent weight ratio to the equivalent weight. When same amount of charge is passed through different electrolyte, it will be related to the chemical equivalence. Okay, so if we are taking two different solutions and we are passing the same quantity of the current through the two solutions, so the amount of ions deposited will be connected to the chemical equivalent weights of the electrolyte that we use. That is the second law of electrolysis. So refer to the starting of the video. We already discussed completely in detail. Okay, so we can go to the next topic. So these are the things that we discussed now. As a mind map, I have given here electrochemistry, chemical energy, electrical energy, interconnected, galvanic cell or voltaic cell. In that we learned about Daniel cell, electrolytic cell. What is electrolytic cell? In electrolytic cell, for you, this is the mind map. You can take the screenshot and it's very easy to learn. Okay, so in electrolytic cell, what is happening in electrolytic cell? electrical energy converted into chemical energy. But in the case of galvanic cell, what is happening? Galvanic cell, chemical energy is converted into electrical energy. Example is Daniel cell. Okay, then, and in the galvanic cell, we learned like different cells, Daniel cell, and we are going to study about the batteries. The next topic is the batteries. Different types of batteries are coming. Then, next one is like the calculation. Delta G is negative, E is positive. For the electrolytic cell, delta G is positive, E will be negative. Electric current reaction, oxidation half reaction, then reduction half reaction, anode, cathode. Anode will be negative in electrochemical cell. Electrolytic cell, it will be positive. Cathode is positive in electrochemical cell, and cathode is negative in electrolytic cell. So learn the differences, my dear kids. So it will be very useful for you. So take the screenshot. This is just a mind map for your easy understanding purpose. Okay, so clear? Any doubts? Okay, right? Okay. Now, commercial voltaic cells. So we are going to the last topic of this chapter, that is batteries. So we are going to learn about batteries, and before that, it's familiar for you the term battery, right? We are using different kinds of batteries in our home for our different purpose, in our vehicles, in bus, in cars, in scooties, not only in bus and car scooties, right? In even torch, in toys, cars, watch. The watch we are wearing is having a battery, right? So different kinds of battery we are using in our daily life. But there are different types of battery also. There are two kinds of battery, and batteries are classified into two types, that is primary battery and secondary battery. Can you state the difference between the primary battery and secondary battery? What are the major differences between primary and secondary battery? And here it is given like voltaic, commercial voltaic cell. What is my voltaic cell? So no need to refer like commercial voltaic cell. You can learn like battery. Okay, battery. Battery, we can write the classification. No need to look at here. We can write according to our textbook. That is somewhat related to the NEET syllabus. Okay, here battery. Batteries are classified into two types. The first one is primary battery and the second one is secondary battery. Primary battery and secondary battery. Okay. And the major difference between the primary and secondary, can anyone tell the major difference between the primary and secondary? I will call their name if they tell the answer. No one is answering. Why? What happened to you? My dears, primary battery means it can be only used once. When the chemical reaction ends, the battery is died. We can only throw it, otherwise no use of that. For example, the watch battery. The watch I am wearing is having a battery. Can I recharge it? No. Can I reuse it when it is dead? When the chemical stored inside the battery is consumed for the purpose, for this watch purpose, the energy will be consumed. So it is over. When the chemicals are consumed, we cannot use it again. The battery becomes dead. It cannot be reused, cannot be recharged. That kind of batteries are known as primary battery. The life is only one time. When the charge is over, it is dead. But in the case of secondary battery, secondary means what? It can be reused, recharged, and we can use many times. Rechargeable, yes, very good, money. Primary can be used once and secondary is rechargeable, yes, very good. So, primary battery means it can be used only once and cannot be recharged. Can we charge the watch battery? For smart watches, it is okay. The smart watches battery comes under the category of secondary battery that can be recharged and reused. Okay. But in the case of the old, like this watches, it is not rechargeable, not reusable. When it is over, it is dead. We can throw it off. Okay. Then, dry cells and alkaline batteries are the example. Dry cells means the small batteries that we use in our watch, the radios, TV remotes, toy cars. Okay, they are the dry cell batteries. When the charge is over, it is dead. It is not rechargeable, not reusable. It is dead. We can throw it. Okay, clear? That is primary battery. Learn the examples. That is dry cell and alkaline cell. And the next one is secondary battery. Secondary battery means that can be used more times. When the charge is over, we can again recharge it. charging, recharging cycle, charging, discharging cycle. 2 cycles will be the charging, discharging cycles. So we can use it again. And secondary is rechargeable, reusable, it won't die. So it can be recharged many times. Example is nickel-cadmium cell and lead storage battery is very important. Lead storage battery we are using in our vehicles and in inverters. When there is no current, we are using inverters in our home. No, you will say big battery. What is happening there? We are storing, right? Chemicals will be stored there. So that energy we are using. So a rechargeable cycle. So electricity will be used there. So it will charge again. Then the chemicals will be used. Then like recharging, discharging cycles will be. Charging, discharging cycle will be there. Okay, Nishita. Okay. So it can be recharged, reused. That is secondary battery. Now we are going to learn about in detail about the different examples for primary and secondary. For primary 2 will be there and secondary 2 will be there. And that total 4 are very important for your last final exam. Daniel C we already learned. Okay. Primary cell. Ma'am will come in 2 minutes. Okay. Just 2 to 3 minutes break. I will come in 3 minutes. I want to just drink a little water and I will come back in 3 minutes. Okay. Wait here. Don't go anywhere. I will come in 3 minutes. Okay, my dears. It's not money, okay? That is Nishida. Dr. Yuvaraj Banjara. That is Nishida, not money. Okay. So, come back. We can discuss the primary battery. So, batteries are of 2 types, primary battery and secondary battery. Primary batteries means what? It's not rechargeable. Live. Okay, so primary battery and secondary batteries are the primary batteries means what? It's not rechargeable, it's not reusable. When it is dead, it is dead. We can throw it off, we cannot reuse it. The batteries that we use in our watch, toy cars, torch, radios, TV remotes are the examples for primary battery, and you are familiar with this picture, right? That we use in our radios and TV remotes, AC remotes. So this is the construction. Here, a cathode will be there and the cathode is positively charged and anode is there. Anode is usually zinc metal coated with a zinc covering will be there, and inside that covering, we will be coating it with moist electrolyte paste. A moist electrolyte paste will be filled in that battery, okay? Then paper card or a salt bridge will be here. This is known as the red color is the paper or the cardboard salt bridges present between the red. Okay, so this is the construction, this is the picture of the primary battery. And primary battery, 2 examples we want to learn is dry cells, mainly the dry cells that we use in our watch and the toy cars. Okay, so the next one, what kind of reactions are happening in the dry cell? And this is very important for your boards. 3 equations we want to learn: anode reaction, cathode reaction, and the final net reaction happening inside the battery. That is, first one is the anode oxidation. In anode, oxidation will take place. The first reaction here, NH4 plus 2 electron. What will happen when we are taking the ammonium? NH4 plus 2 electron, it will change into NH3, ammonia, NH3. Then anode oxidation, zinc. If it is zinc, what will happen? We learned in the Daniel cell that zinc undergoes oxidation. Zinc changes to zinc Zn2 plus. Okay, Zn2 plus 2 electron. So, first one is cathode. Okay, here it is cathode reaction. This is the cathode reaction. The other one is the anode reaction. So, cathode reaction and anode reaction combines together to form the total reaction. Okay, why anode and why cathode? Because in a battery, in a cell, 2 electrodes are necessary, right? One is cathode and the other one is anode. Then only the reaction will take place, right? That's why. Okay, so anode reaction will be the cathode reaction. In the cathode, ammonium is there. Ammonium undergoes reduction. Reduction means what? Gaining of electrons. So ammonium adds 2 electron, it changes to ammonia, NH3. Okay, then in the anode, zinc undergoes oxidation. Zinc changes to Zn2 plus 2 electron. There happens the losing of electron. And when we add the 2 electron, we will get the net reaction. The net reaction is written here. This is the net reaction. The pressure will be built up and the cell is ruptured by the formation of 2 gases at the cathode. That is Zn2 plus 2 NH3 plus 2 Cl gives ZnNH3 twice Cl2. Okay, ammonium chloride. Actually, it will be ammonium chloride. Okay, then no need to look at this equation. There is a little bit confusing things are there. You can use your text, not this one. Okay, this one is not required actually. Okay. It will be like ammonium and zinc will mix together. Then next one, manganese oxide will be, if you get type, just take an old battery and break it. You can see a black color powder, and that black color powder is mixed in the battery. That is manganese dioxide MnO2, and MnO2 mixed with hydrogen, reacts with hydrogen, and it will change to manganese Mn2O3. And H2O. So that is the other reaction happening inside the dry cell. So these are the reaction we want to learn. First reaction, second reaction, and the third reaction. There is a mistake in here. So we can write like, it will form ammonium chloride, NH3Cl. Ammonium chloride will be formed. Okay. Clear? Any doubt? Any doubt here? Ammonium chloride. Okay. Ammonium chloride will be formed. That is NH4Cl. Then ammonium chloride. Here there is a slight mistake is there. That will write here. NH4Cl. Ammonium chloride will be formed. Okay, so we can go to the next battery, primary battery. You got it right. So we cannot recharge it and reuse it. It is dead. When the full energy is consumed, we cannot reuse it. Okay, so the next one is the other example. Here it is given the paste of MnO2. This is the equation that we discussed now, that the picture is given here. Anode will be made up of zinc and inner case. The inner case is made up of the zinc, that will be the anode, and cathode is made up of the graphite rod. Graphite rod means carbon. Graphite means what? Carbon. And a paste of MnO2, NH4Cl and carbon is mixed inside the cell. Okay, this is mixed in the cell. Then secondary or rechargeable battery. I haven't written anything on the slide. So what will be the things in the secondary battery, my dears? What is a secondary battery? Can you tell? Secondary and primary battery. Secondary battery, what are the points? Secondary battery. What will be the major points? They are rechargeable batteries. Then the energy stored until that can be charged, discharged and reused many times. Got it? So, or a secondary battery, the batteries can be recharged. That's why it is known as rechargeable battery. Recharged, then it can be recharged, reused. After the charging cycle, what will happen? Charging, discharging. 2 cycles are happening inside the battery, that is charging, discharging, and again we are reusing it. So we can reuse it by charging many times, so it won't stop, so it won't die, so we can use it many times. Examples are the battery that we use in our vehicles, vehicle batteries. Used in vehicles, where we are using it? In vehicles, inverters, generators, inverters are we are using, then torch, rechargeable torch. Okay, smartwatch. In smartwatch, we are using it, smartwatches. Then, we are using many places, we are using the rechargeable things. No, mainly mobile phones. Mobile phones, we are using lithium batteries. Mobile phones. Okay, clear? In mobiles, we are using the lithium batteries. So, the main examples are what? The main examples. What are the main examples for the secondary battery? For the secondary rechargeable battery, there are a lot of examples. We already discussed in the beginning. The first one is lead storage battery. I will show you the picture. This is the lead storage battery. Have you ever seen this battery anywhere? Have you seen this battery anywhere, my dears? This is the battery that we are using in our inverters, vehicles. A big box will be there, no green color box. That is a lead storage battery, and the construction is given here. Plus is there, minus is there, you know, cathodes will be there, anodes will be there, and it is made up of lead. Okay, PbO2, lead oxide is there, and sulfuric acid. Plates in the solution here of sulfuric acid and water. So, in the lead storage battery, discharging reactions will be there and charging reactions will be there. The discharging reactions are lead. It is made up of lead oxide. So, PbO2, then it is H2SO4, sulfuric acid, reacts together to form, what will happen? PbO2, H2SO4 reacts to form PbSO4, that is lead sulfate. We will get lead sulfate plus water. That is the first reaction, cathode. Then anode oxidation, we are writing MnO2, manganese oxide will be there inside the battery. Manganese oxide react with hydrogen, it will form Mn2O3 plus H2O. Then the total reaction, this reaction is actually not required here. So only the first one is the main one. Okay, then so what will happen when we add the reaction Pb? No need to focus on this reaction. Okay. So in this reaction, PbO2 plus 4H plus SO4 2 minus plus 2 electron, it will form lead sulfate plus water. That is the final equation for the lead storage battery. Okay, so you should learn the individual anode reaction and cathode reaction, and the final net reaction that is given by PbO2 plus 4H plus SO4 2 minus gives PbSO4. Clear? So PbSO4 will be the product and it undergoes charging discharging cycle, so we can reuse it by charging. Okay, so when the charge is over also we can reuse it by charging. So according to the charging cycle it will work. So this is the battery that we are using in our vehicles, inverters as generators. Okay, clear? So we can store the charge in the battery using the chemicals. We can use it when it is required. Charge it, consume it, and we will use it. Okay. So the next one, the net reaction is given here. This is the main net reaction. Here we discussed PbO2, 4H plus SO4 2 minus, it will gives PbSO4 plus 2H2O. So the net reaction, Pb plus SO4 2 minus gives PbSO4 plus 2 electron. Charging reaction is the reverse of discharging reaction, with the reaction on anode will be written on the cathode and vice versa. Charging reaction is there, okay. Charging reaction is reverse of discharging reaction, with the reaction on anode will be written on the cathode and vice versa. So my dears, study this equation, that is very, very important. So that is very important for the lead storage battery. Focus on that, okay. Clear, right? Then we are going to the next reaction. Nickel-Cadmium Battery. Next one is lead storage is over. We are going to the last one, that is nickel storage, Nickel-Cadmium Battery. Okay, Nickel-Cadmium Battery we are not using because it is very, very expensive actually. Okay. Nickel-Cadmium Battery is very expensive, so only need to study the two equations, how it is made up of. It is made up of nickel and cadmium, and the reactions are given here. The first reaction is, look here, nickel oxide plus water plus 2 electron gives nickel hydroxide, NiOH twice plus 2OH minus. So first learn that equation. Then anode oxidation is given by cadmium plus hydroxide, Cd plus 2OH minus gives CdOH twice, cadmium hydroxide plus 2 electron. So the net reaction will be very, very important. The net reaction is given like NiO2, nickel oxide, plus, how we will write the net reaction? First write the cathode reaction. NiO2 plus 2H2O. NiO2 plus 2H2O plus 2 electron gives NiOH twice plus 2OH minus. That is the first reaction, cathode reaction. Okay. Yes. Okay. Then second one, anode. Cadmium plus 2OH minus gives CdOH, cadmium hydroxide, plus 2 electrons. So how we will add it? When anything is coming similar on the opposite side, we can cut it. Just look at the opposite side. Here 2 electron, here 2 electron, that we can cut. OH minus we can cut. So add it and write, that will be the total final redox reaction happening there. Okay. So how it is? NiO2, nickel oxide, plus 2H2O remaining. One Cd is there, that we can write here, Cd gives. Then what is on the right side? Nickel hydroxide, NiOH twice plus cadmium hydroxide, CdOH twice. So these are the two products formed in the nickel cadmium cell, and it's very, very important. So study the cathode reaction, anode reaction, the final net reaction. Okay. So for these three equations, it will be asked for 2 marks. Okay. My name is Harita. Okay. So the last one is the fuel cell. Fuel cell, what is fuel cell? Fuel cell is made up of hydrogen and oxygen. Hydrogen and oxygen will be pumped and it will form water, and it is having the less pollution. Why it is having less pollution? The byproducts, the product is what? The hydrogen combines with 2H2 plus O2, 2 hydrogen plus oxygen gives 2H2O. Water will be the product in the fuel cell. Okay, so this is the picture of the fuel cell, and hydrogen ions will be there, then oxygen molecule will be there. It will combine together to form what? My name is, okay, Harita. So it will combine to form water. H2 plus O2 will give water, H2O. So that is happening inside the fuel cell, and is a less polluting cell. There is no pollution for the fuel cell because the product is what? Water. So there won't be any pollution. Okay. So cathode reaction and anode reaction is given. The oxygen plus 2H2 plus 4 electron give 4 hydroxide OH minus. In anode, what is happening? Hydrogen, that is 2H plus 2 electron gives H2. Okay, this is the final reaction. We can write like cathode reaction. First, I'm going to write the anode one. Okay, H2 gives hydrogen 2H plus 2 electron. The other one. Next one is oxygen. So oxygen plus 2H2O. 2H2O plus 4 electron gives 4 OH minus. Now we are going to add the equation. So the final equation, can you tell what will be the final equation? The final equation will be what? H2 plus O2 We can cut it, right? H2 plus O2 gives 2H2O is the final equation for our fuel cell. It is made up of hydrogen and hydrogen and oxygen, made up of hydrogen and oxygen. So the pollution will be very low and it is the safest one to use. Okay, so the less polluting, it can save our environment from the pollution. Then learn the two equation. Then next one is corrosion and its reaction. What is corrosion and what is the reaction happening there? Okay. Corrosion, okay. A corrosion system can be regarded as a short-circuited electrochemical cell in which anodic process is something like Fe undergoes oxidation to Fe2 plus and cathodic steps are given by oxygen plus 2. Many reactions are given. Just listen. Corrosion means what? Metals reacts with the surrounding atmosphere, right? Oxygen will be there, water will be there, air will be there. So the metals react with the surrounding air. And what will happen? What will happen? Metals react with the surrounding moisture, air, acid, salt, and it will change into metal oxide. That process is known as corrosion. Examples are rusting is there, tarnishing is there, like verdigris is there. Lot of examples are there. So metals undergo reaction with the surrounding air, water, acids to form metal oxides. Okay, I'm from Kerala. So metal oxides. So that process is known as what? Corrosion, and corrosion system can be regarded as a short-circuited electrochemical cell. It behaves like an electrochemical cell. That's why we are learning the corrosion in this chapter. So what happened to the iron? Iron undergoes oxidation. Iron is actually 0. Fe undergoes rusting. We are dealing with the rusting. Iron undergoes oxidation, it changes into Fe2 plus 2 electron, and the cathodic steps are given by O2 plus 2H2O plus 4 electron. It will change into oxygen, will change into hydroxide. Okay, so this is happening there. This is the method to prevent the corrosion. How we can prevent the corrosion? So you should learn the process happening in the corrosion process. One picture is given in your textbook. I will show you now. Wait 1 second. Okay. Just a minute. Here you should learn like Fe. Fe is changed into Fe2 plus. Fe undergoes oxidation, it changed into Fe2 plus. Then in the presence of oxygen, it is undergoing the corrosion. So oxygen will change into oxygen, reacts with the water. Oxygen with water plus 4 electron, it's changed into hydroxide 4OH minus, or you can write water also. Okay, 4OH minus. So this is happening in the case of corrosion. So instead of the second equation, we can write like O2 plus 4H plus. I will write the other equation. O2 plus 4H plus 4 electron, it will change into 2H2O. So this is the final equation, and when we combine these two equations, we will get like, what will be the final equation? Can anyone write the final equation? The final equation will be the overall reaction Fe plus O2 plus, I'm writing the final equation here, Fe plus O2 plus, then what is remaining there? Fe plus O2. The other things we will cancel. 2 electron, 4 electron we cancel. H2O, then 4 hydroxide we can cancel. So what is remaining there? Fe plus O2 plus 4H plus gives, what is it? Fe2 plus. Clear? Fe2 plus, that is the rust, ferrous. That is very, very important. Fe3 plus, and that is the rust, known as rust formation. Rust. So for this, you will be getting the 1 mark. Fe will be changed into Fe2 plus. That ferrous is known as the rust formation. That is the process known as corrosion, the reaction of metal with the surrounding medium to form, and will undergo oxidation. That process is known as rusting, and it comes under the category corrosion. Clear? And how we can control the corrosion, how we can prevent the corrosion? There are many methods to prevent the corrosion. Generally, we are using a lot of methods in our homes like painting, oiling, greasing. These methods help to prevent the corrosion. Other than that, the main method is galvanization. What is galvanization? Coating the metal with other metal. Like we learned in electroplating, is like similar to electroplating. Coating one metal over the other metal can prevent the corrosion. Okay, so here when coating a more reactive metal over the less reactive metal can prevent the corrosion of the less reactive metal. For example, if we are coating, for example, if we have iron will undergo corrosion. So to prevent that, if it is iron, we can give a coating made up of zinc. We can coat the iron with a zinc metal. So why? Zinc is more reactive compared to iron. So the zinc will react with the water, acid, the oxygen, everything. First the zinc will react with the other mediums, the surrounding mediums, and it will undergo the destruction. So we can save the iron from the further reaction. That is a method known as coating or electroplating method, similar to electroplating, that is galvanization. Galvanization means coating one metal over the other metal. We will be using a highly reactive metal to coat a less reactive metal. Here the highly reactive metal, if we are using zinc, that process is known as galvanization. So we can use a more active metal and it is coated over a less reactive metal. So we can prevent the corrosion. Okay. Clear? Any doubt? So that is a one method to prevent the corrosion. The other methods are painting. We can do the painting over the metal, so it won't react with the surrounding medium, and we can do oiling, we can do greasing. So these are the methods to prevent corrosion. And in India, we are lacking lot of crores of monies per year due to the corrosion. Like in India, lot of things are made up of iron, metals like bridges, ships, construction purpose. So they're happening a lot of corrosion daily, on a daily basis. We're lacking crores of money. So how we can prevent this corrosion can be asked as an application question. We can do galvanization, that is coating one metal over the other metal, and we can do painting, oiling, greasing. So these are the methods to prevent the corrosion. Okay. Then other one is not cathodic protection. Okay. Cathodic protection. By maintaining a continuous supply of negative electrical charge on a metal for inhibition of dissolution of positive ions, these things just no need to read. It's like a NEET syllabus I have given here. Cathodic protection, that means anode. For example, we are having two metal 1, metal 2. We want to save the metal 2. Listen here, metal 2 will be less reactive. Okay. And metal 1 will be more reactive. We are taking two metals. Metal 1 will be more reactive and metal 2 will be less reactive. So, if we want to save the less reactive metal, what we can do? We can coat the metal 1 over the metal 2, like the same process, galvanization. So, when we coat the metal 2 with metal 1, that is highly reactive. Okay, highly reactive metal, what will happen? The highly reactive metal will react with the surrounding medium like oxygen, air, water, moisture. So it will undergo the corrosion process. So we can protect the M2. And we already learned that a highly reactive metal, the highly reactive metal will be what? Anode. Highly reactive metal, it will be anode, and less reactive will be cathode. So using an anode, we can protect the cathode, only that much. That is cathodic protection. We protected the cathode by using a highly reactive metal. So by this manner, we can protect the other metal just coating the one metal over the other metal. Is that clear? Okay. So in this chapter, what all things we learned? We learned about what? Electrochemical cell. Two cells we learned. Okay, electrochemical cells. In the electrochemical cells, the main thing was what? It is also known as galvanic or voltaic cell, and we learned an example for the voltaic cell, that is what? Daniel cell, made up of zinc and copper. And from that section, we learned about the calculation of E cell, that is cell potential, then Nernst equation, then the calculation related to the Nernst equation, equilibrium constant Kc. Okay, then we learned about the resistance. Resistance is very, very important. Resistance, conductivity, resistivity, then what? Kappa. Resistance, resistivity, conductance, conductivity. These four terms are very, very important. Okay, then we have gone to the electrolytic cell, that's just opposite. What is electrolytic cell? In electrolytic cell, electrical energy is converted into, electrical energy is converted into chemical energy. Electrical energy into chemical energy. In the previous one, electrochemical cell, chemical energy is converted into electrical energy by the means of redox reaction. By the means of redox reaction. Chemical into electrical by the means of redox reaction. But in the case of electrolytic cell, electrical energy is converted into chemical energy. Clear? So these are the main topics that we discussed. After that, we discussed about the batteries and the two types of batteries, like primary is there, secondary is there, and the major difference between the primary and secondary, and there are examples. Primary batteries means what? They are not reusable, not rechargeable. When it is over, it is dead. Examples are dry cell that we use in toys and watch. Then secondary means it can be recharged, charging cycle will be there, discharging cycle will be there, so we can recharge and reuse it, and for many purpose, for many years we can use it. The batteries that we use in our phone is an example. Lead storage battery used in vehicles, inverters, and nickel-cadmium cell, it is not used as like lead storage because it is expensive. It is made up of nickel and cadmium. And then we learned about the fuel cell. Fuel cell is the most suitable one for the environment, less pollution, because the hydrogen and oxygen is used. Hydrogen and oxygen will be pumped from the opposite sides and will form the water, H2O. So it is less polluting for the environment. So it is very good for our environment. Okay, clear? So that much we have discussed. And the last topic was corrosion and how we can prevent the corrosion. Corrosion, how the corrosion is happening. A metal react with the surrounding medium and it will change into metal oxides. Like iron will change into ferrous oxide, Fe2+. Okay, so that process, the reaction with oxygen, the cathodic protection, anode, how it is happening, anode cathode reactions, the total reaction. Then the last one we learned about the protection thing, that is galvanization, cathodic protection, painting, oiling, greasing, other methods to prevent the corrosion. Only that much from this chapter. So we have discussed the full topics. Okay, so if you have any doubt, you can ask in the comment section. We can clear the doubts. So you are ready to attend the exams, right? I think you are having the midterm exams now. It's a time for the midterm exams. In 2 or 3 months, everything will be over. All chapters will be over. You will be dealing with the practicals. And from the next class, we are going to deal with the third chapter, that is chemical kinetics. So this class is okay for you. You got it, right? If you have any doubt, you can ask in the comment section. So we can wind up today's class. No one is asking any doubt. So we can wind up, right? Okay. So, bye-bye everyone. Bye. Thank you.